Hi, this is the second part 2 of radian measure on the unit circle. If you haven't seen part 1 yet, I certainly recommend that you do that first. We join our lesson, already in progress.
All right, well, so we're talking about angle measures now and radian measures, both on the unit circle. And so just like the sine of 30 degrees is the y value, 1/2, so too is now sine of pi over 6. Same location, same y value, the sine of pi over 6 is 1/2. And we're going to be doing trig values, trig functions, using our radian measures. So the first thing we have to do is locate things. Now all of these happen to have a denominator of 6. And so theta hat each time is 30 degrees. But again, it's important to locate them in the proper quadrant so that we can find out whether it's positive or negative. And of course, it'll somehow be related to 30 degrees and square root of 3 over 2, comma 1/2 for the x and the y. So when we look at the sine of 5 pi over 6, we recognize, oh, that's in quadrant 2. And sine is positive in quadrant 2. And sine is the y value for 30 degrees. So that's going to be a 1/2, positive 1/2. For the cosine, 7 pi over 6, that's located in quadrant 3. Cosine is negative in quadrant 3, so we'll start off by saying this is equal to negative. We just leave it negative for the moment. Don't know what it is yet till we do. I mean, it's 30 degrees. But in general, when we don't know automatically what it is, we, get the negative down first and then decide what the value is that follows. Tangent in quadrant 4, 11 pi over 6 in quadrant 4, tangent is negative in quadrant 4. So that's the first thing that we're going to include here. Tangent is negative. Then we have to look at the value of the tangent. Now, that is not directly on the unit circle, so we could figure it out by doing sine over cosine. You can see that happening right here. Or if you happen to have a table of values, you could look up tangent of 30, and what would you discover is that it's square root of 3 over 3. That's exactly what we get for this answer. It's the negative because it's in quadrant 4, but it's square root of 3 over 3. Let's do that for now 60-degree related angles, which means pi over 3. So again, I'm going to label pi as 3 pi over 3 and 2 pi as 6 pi over 3. We can do that any time it's helpful to us. Now all of these happen to be denominators of 3. Typically though, when you're given these values, then one will be pi over 3 and the next one will be something over 4 and then a pi over 6 or whatever, or maybe one of the axial values. So we'll be using the 60-degree mark where x is 1/2 and y is square root of 3 over 2. And the sine is in quadrant 1, pi over 3 in quadrant 1. And so that's just the y value. It is positive. It is positive at 60 degrees, positive square root of 3 over 2. For the cosine, 5 pi over 3, we locate that. That's quadrant 4. And cosine in quadrant 4 is positive. So we put that down right away. And then we think about it. Let's see, pi over 3, let's see, that's related to 60 degrees. Oh yeah, there it is, 60 degrees. And that's an x value, so the cosine, the x value is 1/2 for pi over 3, and that's positive 1/2. 4 pi over 3 is a quadrant 3 value, and tangent is positive in quadrant 3. Now again, if you don't already have this in your chart somewhere, or an easy access, or maybe you have it memorized, then you kind of need to figure it out. Hopefully though, what you want to do is not have to figure it out each and every time. This we see here is equal to square root of 3, and so the answer there is positive square root of 3. Now I use a plus sign for each of these. Plus sign is not required, simply recommended because it really just emphasizes the fact that they are positive. Let's do the same thing now for 45 degrees. Again, starting with the pi and the 2 pi written with a denominator of 4. And we know that the ordered pair for 45 degrees is the square root of 2 over 2 for both x and y. Pi over 4 quadrant 1 is positive. Sine of the y value, it's the square root of 2 over 2. For part B, the cosine, 5 pi over 4, that's a quadrant 3 value, and cosine is negative in quadrant 3. At the 45 degrees, again, square root of 2 over 2, but the answer here for cosine of 5 pi over 4 is negative radical 2 over 2. Now, you might have this tangent memorized. It's a nice one. First of all, quadrant 4, tangent's negative, but sine and cosine are the same, so we get just 1. And that ends up being negative 1. Let's look at some axial values now. Consider these for 3 pi over 2 and 5 pi over 2 and negative pi over 2. It's a good idea to write these down and be real careful with the ones and zeros. It's very easy to get them mixed up between x and y axes. So all of those happen to have a denominator of 2. That's why I'm writing these with 2's. And one of them is 5 pi over 2. And it's not in our normal once around the unit circle, so it's good to see by counting by pi over 2, we can locate 5 pi over 2 at 90 degrees. So the sine of 3 pi over 2, that is at 270 degrees, and we see the y value there is negative 1, and that's the answer. For part B, x, the cosine is of 5 pi over 2 at 90 degrees is 0. Now at C, the tangent, again, either we have it memorized, or it's somewhere in a table, or we just go ahead and figure it out like we're doing right here. And that's undefined. Negative 1 over 0, 1 over 0, undefined. And you can abbreviate that if you want to. Now let's do a set where the argument is the angle measure, pi value is just like pi and 2 pi. And you see here also negative pi. Again, it's good to write the ordered pairs around the unit circle. We see where pi and 2 pi are located. And negative pi is same place as 180 degrees or negative 180. Sine of pi is the y value at pi, and that's 0. No quadrants to figure out here. These are axial values. The x at cosine of 2 pi is 1. So there it is. Now the tangent, in this case, we'll look at pi, the sine of pi over cosine pi. I know it says tangent of negative pi, but it's at the same location as pi, so let's use it. 0 over negative 1 is 0. So the tangent of negative pi is 0. Well, that's all I have for today. Until next time, take care.